Hello friends, so far we have learned about polynomials. We defined a polynomial, we named various kinds of polynomials like linear polynomial, quadratic polynomial and cubic polynomial. We also gave them names like first degree polynomials, second degree polynomials and third degree polynomials, and we said that we can name any polynomial just like that. So I hope all of you understood that very well. Now we are going to speak about zeros. Of course, we spoke about zeros in the last class, that the zeros of any polynomial is the value of the polynomial which when substituted gives us a zero, right? That is, for the polynomial ax plus b, let p of x is equal to ax plus b. We said that it is a linear polynomial and the zero of this linear polynomial is nothing but minus b by a. We proved this result in the last class. Now we are going to interpret the zeros of a polynomial graphically. You know the graph of any function. The graph of any function is the geometrical plotting of the function, right? We shall plot the graph of a function. Let y equal to 2x plus 3 be our polynomial. Of course, it is a linear polynomial as well as it is a first degree polynomial. Let this be our polynomial. Now we are going to interpret the zeros of this polynomial graphically. See, from this expression itself we know that the zero of this polynomial is nothing but minus 3 by 2, since it is of the form ax plus b, and we know that the zero of any polynomial of the form ax plus b is equal to minus b by a. Hence we have for y equal to 2x plus 3, the zero of this polynomial is minus 3 by 2. Now we shall plot the graph of this function. How we can plot the graph of this function? For any function to plot graph, we should name it as y is equal to 2x plus 3. So our polynomial is 2x plus 3 and we return it this like this, y is equal to 2x plus 3. Now we are going to plot the graph of this function. Since it is a linear polynomial, of course we know that the graph will be a straight line. See, this polynomial is named as linear polynomial, right? And linear, see, the first word is line, which means that for any linear polynomial the graph will be a straight line. So always keep in mind that for any linear polynomial the graph will definitely a straight line. So the graph of this function will also be a straight line. Now we can plot the graph. For that we are plotting, in order to plot graph we need points. For that let we put x and y is equal to 2x plus 3 as columns and rows like this. When x is equal to 1, y is equal to 2 into 1 plus 3 equal to 5. So whenever x equal to 1, y will be 5. And when x is equal to minus 1, y is equal to 2 into minus 1 plus 3 equal to minus 2 plus 3 equal to 1. So we can substitute any value for x and we can substitute any value for x like this, and we get corresponding values for y as like this. So now we can plot the graph of the function like this. In order to plot the graph of any function we need to draw x-axis as well as y-axis. So this is our y-axis and this is our x-axis, and let us mark points 1, 2, 3, 4 and 5, minus 1, minus 2, minus 3, minus 4, minus 5. Always remember that in order to draw the graph of any function we should draw a coordinate plane like this. So always keep in mind that we should draw x-axis as well as y-axis to draw like this. Now we have x-axis as well as y-axis plotted with points on it. Okay. Now we know that when x is equal to 1, value of y equal to 5. That is, whenever x equal to 1, the value of y will be 5. That is, the point is nothing but 1, 5. So our point will be here. Whenever x equal to 1, y equal to 5. So in order to plot the graph, we should mark the point like this. See, 5. Okay. Now whenever x equal to minus 1, that is whenever x equal to minus 1, y is equal to 1. That is whenever x equal to minus 1, y is equal to 1. So our point will be like this. So we got 2 points. Hence we can draw the graph of the function through these 2 points like this. See, this will be the line for the graph. We can highlight it using another ink. See, this line will be the graph of our function. We marked 2 points here, and the straight line passing through these 2 points will be the graph of this function. See, this point is in the middle of minus 2 and minus 1. So it will be minus 1.5, right? Minus 1.5, and the y coordinate is 0 since this point is on the x-axis. Now minus 1.5 is nothing but minus 3 by 2, right? See, minus 3 by 2 was our 0 of this polynomial. So minus 3 by 2 or minus 1.5 is obtained whenever this line crosses x-axis. Don't you feel any connection between this? See, our 0 of this polynomial was minus 3 by 2, and minus 3 by 2 is obtained when this graph crosses x-axis. So we can say that for any linear polynomial, the 0 will be on the point of the x-axis where the straight line or the graph of the function crosses x-axis. That is, whenever the line crosses x-axis, we can find a corresponding x point here, and that will be the 0 of the function. Clear? Also note that the straight line, whatever be the straight line, it can cross x-axis only once. So a linear polynomial will definitely have one and only one 0, because a straight line can cross the x-axis only once, and that will be the 0 of the linear polynomial. Hence, now we shall discuss about this geometrical meaning of zeros of a second degree polynomial. We know that a second degree polynomial can also be named as a quadratic polynomial. Also, it is of the form a polynomial with form ax square plus bx plus c. Right? Now we have y equal to x square minus 3x minus 4 as our polynomial. We are going to plot the graph of this polynomial. This is a second degree polynomial. Before we plotted the graph of a first degree polynomial, and we found that it has only one and only one 0 because it crosses the x-axis only once. Now y equal to x square minus 3x minus 4. When x equal to minus 2, y is equal to 6. It is enough to substitute x equal to minus 2 here. When x equal to minus 2, the value will be minus 2 the whole square. 3 into minus 2 minus 4 equal to 4 plus 6 minus 4 equal to 6. See, when x equal to minus 2, the value will be 6. Similarly, when x is equal to minus 1, the value will be 0, and so on. We substituted various values for x and we got various values for the polynomial. Now we can plot the graph of this function just like before. When x equal to minus 2, that is x equal to minus 2, y is equal to 6, that is minus 2, 6. See, this is a point on the graph. Now when x equal to minus 1, y equal to 0, that is when x equal to minus 1, y is equal to 0. So this is a point, minus 1, 0. Here x value equal to minus 1 and y value equal to 0. Now when x is equal to 0, y equal to minus 4. See, x equal to 0 is here, y equal to minus 4 here. So the value is 0 minus 4 here. And when x equal to 1, the value is minus 6. 1, 6, minus 6. So this is also a point, minus 6 here. When x equal to 1, y equal to minus 6. 2 equal to, when x equal to 2, y is equal to again minus 6. So 2 minus 6. This is minus 6. So 2 minus 6 again. When 3, x equal to 3, value will be minus 4. So 3 minus 4. So this is also a point on the graph. See, we are plotting the points like this and we got a shape like this after joining these points. That is, first of all we have to identify the polynomial, then we have to plot a column like this, then we have to substitute various values of x, correspondingly we get various values for y, and we are plotting each point on the graph, then we are joining those points with our marker, and at last we got a shape like this, and this shape is called as parabolic shape. No need to memorize it. This is a shape and this is the shape of a second degree polynomials graph. Clear? See, this graph crosses x-axis at 2 points, at x equal to -1 and at x is equal to 4. Therefore, we can say that this polynomial has 2 zeros. So, whenever we can say that a quadratic polynomial has 2 zeros, just because that polynomial crosses the x-axis 2 times. If it crosses 3 times, then it will have 3 zeros. But here we have only 2 zeros because the polynomial crosses the x-axis only 2 times, and the zeros are zeros equal to -1 and 4. Since x-axis crosses, the graph crosses x-axis at -1 and at 4. So it has 2 zeros, namely x equal to -1 and y equal to x equal to 4. Is it clear? So here the second degree polynomial is of this type. Suppose that after we drawn the graph, we got a graph like this for the second degree polynomial, or we got a graph like this for the second degree polynomial. See, in these two examples, the graph do not crosses the x-axis. See, here the graph don't cross the x-axis. Also in this example also the graph never crossed the x-axis. In this case we can say that the polynomial has no zeros. Whenever we get a graph like this, and for a second degree polynomial, if we got a graph like this, always remember that the graph of every second degree polynomial is of this shape or this shape, parabolic shape. Now, if we got a graph like this, then we can clearly say that it has no zeros. Okay, now suppose that if we got a graph like this, that is like this, or if we got a graph like this. See, in these two examples, the polynomial's graph touches the x-axis only once. Then we can say that it has only 1 zero. See, 1 zero, no zeros, and 2 zeros. 2 zero happens when the graph moves like this, and no zeros happens when the graph never touches the x-axis, and 1 zero happens when the graph just touches the x-axis. Clearly you can understand it. So then we can generalize this result as the result 1. A linear polynomial has only 1 zero, because the graph of a linear polynomial is always a straight line, and a straight line can cross only once the x-axis. So a linear polynomial has only 1 zero. Result 2. A quadratic polynomial has either no zeros or 1 zero or 2 zero. That is, a quadratic polynomial's graph can either be like this or be like this, or it can crosses the x-axis 2 times, or it can just touch the x-axis. So a quadratic polynomial has either 1 zero, that is when the graph just touches the x-axis, or no zero, that is when the graph never touches the x-axis, or 1 zero, that is just touching the x-axis, or 2 zero, that is crossing the x-axis 2 times. Is it clear? So a quadratic polynomial has at most 2 zeros. Similarly, a cubic polynomial can cross the x-axis at most 3 times. It may have no zeros, 1 zero, 2 zero, or at most 3 zero, because a cubic polynomial can cross the graph of the function x-axis only maximum only at 3 times. Similarly, we can generalize this result for higher degree polynomials. So maximum number of zeros allowed for a polynomial is its degree. So maximum number of zeros, if it can be less than that, maximum possible value of number of zeros available for a polynomial is its degree. So I hope you understood the topic of zeros and its graph well. If you have any doubt, just comment it on the comment bar. Thanks for watching. I am signing off. Bye.